So, IEB Math Paper 1 2020 November memo is what we are going through from start to finish without leaving anything out. And this is, as you can see, directly from Bright Young Brains, because it is I, Levi, doing the things. What am I saying? I'm just trying to get in the groove, man. Haven't recorded in a while. But anyways, let's see. Question 1. What is question 1 saying? We are given the following. Okay, 3 minus this, yada 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 yada. Oh, I'm yawning and I haven't even started. P is not equal to 0. They've just given us a basic quadratic equation here, but there's a P. They say solve for x in terms of P, leaving your answer in its simplest form. So, solving for x in terms of P, leaving our answer in its simplest form. Let's see, let's take everything to one side. This would be 0 px squared plus 2x minus 3, right? Now, obviously, if you're going to make x the subject... actually, no. Let us restart. If you're going to solve for x, right, in terms of P, it means that you have to make x the subject of the formula. Meaning the values that have x, you want to take them to one side. And then the ones that don't, you want to leave them on their own. So, or rather, no. I'm getting confused here. It looks as though, here we'll just need to think of this as like a quadratic equation. So I feel like I'm going in circles. I think maybe it's because I'm still warming up, So this is what we have, né? If you're going to isolate x, then you might as well use the quadratic equation. You see, minus b plus minus b squared minus 4ac, the whole thing over 2a. So here b is the 2 here, so it's like negative 2. B here, it's a 2 squared minus 4. A is a p, you see. And then your value for c here is like negative 3. There we go. And then the whole thing over 2. A value here is a p. So this you can literally leave it like this. If you want to simplify, be my guest. But just like this is 100% fine. Because simplifying, I mean, let's see what you would end up with. X is equal to, this is still just going to be minus 2. Plus or minus in the square root, this is going to be a 4. Let's see, a negative and a negative is going to give you a plus 12, and then the whole thing over 2p like this. You see, this is as best as you can get. As best as you can get. Oh, this is as far as you can go, rather. So let us just move on. Anyways, let's see what the next question says. So the good news is that anything that starts with the hands 100, I feel so comfortable saying 100% of the time, you need to look at the previous question to help you, because you see, a question starting with hands, definitely means that you need to look at the previous question. I feel like I just said the same thing twice, but like, hence or otherwise, determine the values of P for which the roots will be non-real. So remember, the roots of an equation are basically the solutions of the equation. And we know that the solutions of the equation, anything in quadratic format, the solutions of the equation is determined by the value that goes under the square root here, you see. So from what we have done, we can see that the value that goes under the square root is basically this 4 plus 12p here, you see. This 4 plus 12p, this is what's going to determine what kind of roots you have, you see. So if you're going to have non-real roots, then you would need to work out where this value is a negative number, because as long as this number becomes a negative, you won't have any... Oh, snap. Excuse me. As long as this number becomes a negative, you won't have any solutions to this expression, you see. You won't have any values for x. So for non-real roots, you want to work out where this value is below 0. You see, this is the same as working out where delta is smaller than 0, because remember, delta is just b squared minus 4ac, and b simplified b squared minus 4ac, it's just 4 plus 12p there. These are just a 2-mark question, because solving for p here, you know that you're going to have 12p here, the 4 is going to go over, you're dividing by a positive 12, remember, so your sign does not have to flip or anything like that. And then, what you got? What you know about rolling down and deep in the woods? Okay. Huh? What did I just say? What you know about rolling down and deep in the work? I don't know how that song goes, but you know, like on IG, every second week or every third week, you know, there's a song trending. But anyways, let's see. Solve for x, showing all algebraic workings. Oh, this question looks like something from the algebra course. But anyway, solving for x here, the easiest thing you can do is to take the value of this -4, you can take it to the other side. Now, the one thing I can say up front while working out this question is that questions like these, you normally end up with two answers, but usually one of them is correct. So here, to get rid of the square root, we can just square the right and the left, you see. So here, you're gonna end up with like 16 here, but then the square root symbol here cancels the square there, and then you have x minus 2. So solving for x here, you can clearly see that x is equal to, oh, you only have one answer. Nice. Okay, well, I think I was maybe referring to like other questions, you see. And here, let's just test our answer though. Excuse me, I'm so sorry. Like, I'm recording this late in the evening and had a long day, but you know, the grind doesn't stop for no potty. It doesn't stop for no potty. But what am I doing here? Checking the answer, it definitely would balance out, or would it? Well, technically, because remember, if you put a, oh no, wait, no, you have to put it up here, you see, because this is like x is, oh snap, I made a mistake. I shouldn't have to erase the whole thing. And now I'm probably thinking, you're probably thinking to yourself, why did you not just edit it out, bro? Actually, because, okay, maybe because I also wanted to show that, you know, it's easy to make a mistake. And I feel like, yeah, let me just do it nicely. So this 4 would go over, right? So it's going to be x minus 4. And then this is just going to be x minus 2. I think what I was saying in the beginning, I'm going to get a chance to showcase it here, because I'm probably going to get two answers, and only one of them is going to be correct. So here you're going to square the left and the right. And then on the left, you have x minus 2, right? On the right, it's x minus 4 twice, you see. So simplifying this, it's x times x, it's like x squared. And then x times -4 gives you a -4. And then -4 times another -4 gives you another -4. So those two would give you a -8x. And then here, -4 times -4 gives you a 16. So this, if you FOIL out everything, this is what you end up with. Ooh. Hey, if you find me doing a lot of yawning in, I'm sorry. I'm so sorry. I hope you're watching this during the day and you have like so much energy and stuff like that. But anyways, on my side, let's see, everything on one side, you're gonna have -8 minus 1, that's like -9. And then 16 plus 2, that's gonna be +18, you see, because we took everything to one side. Now, here I always use the quadratic formula, but here, I mean, factors of 18 that can give you a 9, that's going to be 3 and 6, I think. Yep, 3 and 6 gives you 9. So here, let's put 3, let's put 6, because 3 times 6 give you 18. However, to get a -9, you'd need to say -3 minus 6, you see. It's going to give you a -9. So here, x is equal to 3, or x is equal to 6. Perfect. So that's for 5 marks. But then here, remember I mentioned, anytime you see stuff like this, always double check your answers, because usually only one of them is correct. Because here, you're probably going to get 4 if you leave it like this. Let's test out the 3. 3 in there would be 3 minus 2, which is like 1, and then square root of 1 is just 1. 1 plus 4 is not 3, so it doesn't look like 3 works out. Let's just check 6. 6 minus 2 gives you a 4. Square root of 4 is 2, and then 2 plus 4 is a 6. So this is the only answer, you see. Here you can just put not applicable, because it doesn't balance out the equation, you see. This is how you get your 5 marks. If you don't have not applicable here and you just left it, you only have 5. You only have 4, you see. That is why what we have said is very important. That's why I think also it's okay for me not to like edit out the error that I made in the beginning, because I was, yeah, it just didn't make sense. Because yeah, anyways, how many marks? 3 mark question, inequality. Here, this is already sorted out for you so nicely, and the only idea is here you can clearly see this would draw a smiling parabola. It would draw a smiling parabola because if you multiply out your two brackets, you see you're gonna have x squared here minus x and then plus 3x and then minus 3. So this is clearly drawing a smiling parabola. You see it's drawing a smiling parabola, and what you also know is that this here is gonna result in you getting an x-intercept of like -3. This gives an x-intercept of like +1. So this is asking where will your parabola, you see, remember this here is this parabola. This is basically asking where is this parabola greater or equal to 0. You see, where does it have y values that are bigger or equal to 0? So we know that the portion where it has y values that are bigger than 0, it's this part here, you see, and this part. Why is my graph doing some funny stuff? Don't worry about my graph, it's not to scale. But you see, for you to be getting these values, you're talking about x values to the left. For you to be getting these values, you're talking about x values to the right, you see, starting from 0 as well, because this is saying bigger or equal to 0. So here you're going to say x is smaller or equal to -3, or x is bigger or equal to -1. There we go, there we go, there we go, there we go. No, 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 no. Oh, excuse me. Let it go. Yo. Yeah, Question 2 says, solve for x if this is equal to that. Wow, such nice questions, man. So this is just, you can just use your calculator here, to be honest. Well, it's a 3 mark question. And yeah, I would have just used my calculator, like legit though, like hello, oh, come on now. Cause in the calculator, yawning again. Yeah, the calculator would have given you the mark directly. Because in the calculator, I would have just said, this is x, right, with 2, 3 there. Writing it out, I would have just done this. I would have just put like a square root symbol with like, what you do now? How do you get rid of this? What? Because when it's square, we square root it. So here you would need to put a 2 with a 3 there. And then here you do the same, you see. You put a square root symbol with the tiny 2 and the 3 there, because what you do on the left you do on the right, and this would give you the calculator. But remember, this is just like a 1 over there. So what am I doing? Like, I feel like I'm stuck, but I'm like not stuck at the same time. And yeah, in the calculator, right, this is gonna give you an 8. But then for questions like these, right, if you see that, wait, I forgot to put the line here. I forgot to put the line there. Yeah, for this is gonna give you an 8 in the calculator, or a -8. Is it gonna give you an 8 or a -8 in the calculator? I feel like, why am I lying, bro? Bro, why are you lying? Yeah, I feel like you're still talking, you're still recording. You're making it so difficult to understand, bro. Just say something simple. Okay, so the simplest way to put this now is, let's actually put it this way. Let's actually do it mathematically without using the calculator, because if you're using the calculator here, you may not get your 3 marks. So here, the first thing you can do for yourself is try and compare what the left side and the right side looks like. For example, our side here, you can put 2 to the power of 2. Now, if you look at the way your exponents are laid out, right, we already know that this is something that we're not familiar with, you see. So the easiest thing for us to do is, if we want to work with the exponent that we're familiar with, like the easiest thing is, if you're going to solve for x, you just want to make this a 1, you see. You want to make the exponent of x equal to 1. You want to make this equal to 1. Now the only way you're going to make this equal to 1 is if you multiply it by 3 over 2, because the moment you multiply it by 3 over 2, it means that you end up with a fraction that is something over itself. So what I mean is, on the left, this here, right, you can put it to the power of 3 over 2, and then if you do this on the left, you just need to do that on the right as well. You see, 3 over 2. So if you multiply this and this, you end up with 6 over 6. And then here, if you multiply, remember, your exponent has been multiplied by that, you end up with 2 to the power of 3. Now here you end up with x is equal to 8. So this is the final answer for me, getting a positive 8. And I mean, like, one way or the other, whether we like it or not, you may be thinking to yourself, is 8 the only answer, or do we also have plus or minus? So I think that's where this kind of work kind of like gets a bit tricky. You know, this way it definitely gets a bit tricky, because you have to think to yourself, I mean, like, this is clearly giving us a positive 8, and then this is clearly giving us just x. But then the reason why you want to end up putting plus or minus here is it's going to be a very strange reason, but I'll try and explain. You see, not I'll try, I will explain. So the reason why you want to end up with plus or minus 8 here is because right in the beginning, right, you have to remember that x with 2 over 3 can be written as x to the power of a third and the whole thing squared, you see. So meaning, regardless of whatever x is, this thing always comes out as a positive. So if you have a negative 8 here to the power of a third, if you square it, comes out as a positive. If you have a positive 8 here and you square it, it still comes out as a positive. So you see, that's why you're going through these memos, so that you can learn different tricks and ways of like identifying certain things, yada yada yada. But I would say this is more like a special case, you see, because here I think if you get like 2 marks for this question, don't beat yourself up for it, because this is just, you know, something that's like, yo, is deep, is very deep. Moving on, B says, solve for x and y simultaneously in the following. This looks familiar-ish. So solving for x and y, I mean, obviously you want to make something that's subject to the formula first. So this is just going to be negative 3x plus 2 on the right hand side. Here you may want to make sure that the way I zoomed in so much, why are you zooming so much, huh? Why are you zooming so much? So here you're gonna have 3x squared and then 3 to the power of 1, and then this is 3x, and then this is like 3 negative 1. So all this being done, what am I even doing? I'm trying to solve for x, right? The funny thing, the crazy thing is, I literally, like, I don't even know why I'm doing this, because it was just instinct for me to like split them up, but I really don't have to, because remember, your base is here. The base on the left is already equal to the base on the right. So for this portion, you can literally just drop the bases and just work with the exponents, because if these sides are going to be equal to each other, then the exponents need to be equal to each other, because the bases are already equal to each other. So here, these two are the ones that you need to solve simultaneously. So clearly, this is equation 1, this is equation 2, and you want to throw equation 1 into equation number 2. So wherever y is, you want to put this there. So this is going to be x squared plus 1. This is equal to x, and then minus y here is like negative 3x plus 2. And then you're going to have the x minus plus what now? It's going to be like 3x and then minus 2. X squared plus 1 day. Let me just double check that I didn't make any dumb mistakes, because I seem to be making a lot of those lately, you know. So this is like, let's take everything to one side. This is going to be x squared. This is going to be negative 4x. And then 1 plus 2 is going to be a positive 3. This factorizing does look like it's bad, because I'm like, you know, Factors of 3 that can give you a 4, it's just 3 and 1. For you to get a -4, you have to say -3 minus 1, you see. So this ends up with x is equal to 3 or x is equal to +1. And yeah, that's our value for x, you see. So to get our values for y, obviously we all know what you got to do. You just take the x values and you throw them into the original equation. So we can throw them in here. X value of like 1 and 3, right? So here, if you put a 1 there, let's see what you got. This is like y is equal to -3 plus 2. That's like -1. And then the other one is a +3 that you have to throw in there, right? So it's like -3 and 3 plus 2. This is like -9 plus 2, which is like -7. Okay, there are your answers. Nothing crazy, nothing major. It is a 7-mark question, so I mean, you don't want to just leave it alone without like double checking your answers or something like that. So always just double check your answers. It's really not gonna cost you much. So let us move on here. Yeah, we are still recording. Yes, I am. Oh well. So this is a new section. It's financial math. Lulu invests 20,000 rand at an interest rate of 4% per annum compounded annually. After how many complete bro, just please read nicely, you know. I feel like I'm losing the plot here. Excusez-moi, let me read nicely. Lulu. So the reason why I'm reading again is because the first time I noticed I was just reading. I was not reading to like take in the information and whatever. So this person invests 20,000 at an interest rate of 4% per annum compounded annually. So compounded annually meaning that the value of I, you don't have to divide by anything. The value of n, you don't have to multiply by anything. And then they say here, after how many completed years will it take for her to invest? Wait, how many completed years? I think the keyword here should be completed years, because I'm pretty sure this is going to be a big factor with regards to the kind of answer that you're gonna have. They said here, after how many completed years will it take for her investment to be worth at least 25,000? You remember, at least means that it could be more, you know. But anyways, so clearly here there's no monthly installment, so it's just a normal compound interest question, you know, 1 plus the interest rate to the power of n. So the amount after this is just 25,000. The amount before this is just 20,000. The interest, as mentioned, it is just 4%. It is not compounded monthly or anything like that, so this is just fine. N is what we're working out, you see. So let us work it out. Let's see what we're gonna get. 25,000, 20,000. What is interest? 4%. You're now 4%. N is n. So working at n, I feel like, to be honest, normally what I like to do is, depending on what I'm working out, I always isolate it first. So here I would have divided by p on both sides, ne? I'd have had a over p 1 plus I, and then to get n on its own, I would have used logs here. I'd have put n on its own. I would have had log, the base of the exponent is just 1 plus I, and then the value on the other side is just a and p there, you see. And then I can just put everything in the calculator, like here, log 1 plus the interest, and then 25,000, 20,000. Now let's put all this into the calculator and see what we get. So yeah, you may think to yourself, why would you do that, bro? Isn't that like so much work? Yeah, this has just always worked for me, you know. So this is gonna give you 5.7, which is where this comes in. They asked how many completed years, so clearly you're gonna need to round upwards here. You see, you can say here, therefore n is approximately equal to 6. Let me write it like this. You see, therefore and is approximately equal to 6 years, you see, because it would take 6 complete years to get at least 25,000. So clearly, obviously, when 6 years fully finish, the person will have more than 25,000, obviously, but the question did ask how long will it take for them to get at least 25,000, and they asked how many completed years. So yeah, just be careful with these kinds of questions so that at least you don't end up getting like 3 marks out of the 4 because you didn't like put the 6 years there and stuff like that. So, or rather, let's say here n is equal to this, and then just say here after 6 years. There we go. That's the way. I like it. That's the way. I feel like I'm going mad. I feel like I am going mad. Actually, no, not really. I'm just, yeah, I'm just zoop. Anyways, where's the next thing? Question 3. What does question 3 say? Question 3 says, given the function this, determine what you get when you put 0 where x is. So, wherever x is, you have to put a 0 there. Meaning that, let's see what you're gonna get here. This is just like 3 minus 4. Bro, wherever x is, you put a 0. Like, why are you not putting the 0 there? Where x is, you're gonna put a 0. And then what else you're gonna get? 3 plus 2 here, because this is negative 4 divided by negative 2. That's a positive 2. So this is like a 5. If x is 0, y is a 5. Determine the value of x for which y is a 0. So here you have to make y a 0. So this is basically, I mean, like, without overthinking it, okay, well, we're not overthinking, we're just like taking note of what's actually happening. If your x value is 0, remember you've gotten the y-intercept here, because remember the y-intercept is where x is a 0, and then here, since y is a 0, we're getting the x-intercept here, you see, just so that we know, free marks. So even use a different color. You know why? For the vibes, man. The vibes everywhere. Yeah. Let's see. Wait, what do I want to do now? Oh, this is going to be 0. This is like 3 minus 4, and then x minus 2, like that. So solving for x, this whole thing can go over to the left. So it's going to be like 4. X minus 2 down here, and this is just a 3, because remember this is together, you see, so that's why when you move this to the left, you can just worry about changing that. So here this is over. I don't know, I didn't give myself enough space here, like, goodness, man. This is a fraction, this is a fraction. You see the 3 there, I just put it over 1 so that we can cross multiply, yeah, cross. Hey, color, give me a nice color. Let's cross multiply. 1 times the 4 gives you a 4. And then this times the 3 is going to be 3 there with like x minus 2, you see. And then solving for x, we have like 3x minus 6 with a 4 there. You can clearly see I didn't give myself enough space here. Like, what a wow, man. So here this is going to be x is equal to 10 over 3. Whew, okay, not bad at all, man. Not bad at all. We love to see it. So moving forward, they said we should sketch the graph of f on the axis provided, and then label clearly, and the axis provided below. Label clearly all asymptotes and intercepts with the axis. So this is a basic question if you have like been going through like the functions and graphs course, and you've like been watching stuff on this channel. Like, this is a basic question, because clearly here your asymptote is where x is a positive 2. So it's like 1, 2, somewhere here, you're going to put your x asymptote. Because remember, the equation of your hyperbola always gives you the asymptote. So if this is a negative, you always take it as a plus on the actual Cartesian plane. That's for the x asymptote only. The y asymptote, you have to be careful here, because you see here, in standard form, you would actually have negative 4, so your a value is a negative, and then this would be on the other side. This would be like a plus 3 here, because this is a positive number anyway. So for the y asymptote, you take it as it is. You see, if it's a plus 3, then your asymptote is going to be at plus 3. So this is a 3 over there. Let us draw this. Hey, what is going on? No, come on, man. Let's do this, do this, do this. There we go. So the big idea here is what you need. So this here, remember I've already stated like quite a couple of times that depending on what this is, if this is a minus, right, you have to think to yourself, on a Cartesian plane, going up is plus, going down is minus, going to the right is plus, going to the left is minus. So if you have a negative a value here, like what you have here, then it means that your curve has to be where plus and minus is. You see where the plus portion is and where the minus portion is, and then here plus is here, minus is here. So your curve has to be here, you see, where you have plus and minus, and then your other curve has to be here. Yeah. Like this, you see, where you have plus going to the right, minus going to the left. Because if your a value was a positive number, then you'd need to put your curve over there and over there, you see, because plus up there, plus to the right, and then here negative to the left, negative downwards, you see. So negative and negative give you a plus, and then positive and positive also give you a plus. Anyways, this is your shape. You can clearly label your x intercept as you already got it here. Is just 3 over 10, I mean 10 over 3. And then your y-intercept here, we got it to be, what is the y-intercept again? We got it to be like a positive 5. So I can just label this 5 here. Oh, what did we just do? I think I mixed them up. Y-intercept is a 5. Hey, bro, come on, man. Come on, bro. Come on. Y-intercept, we got it to be a 5. X-intercept is the one that's 10 over 3. So yeah, because I was looking at my sketch, I was like, these don't look like it's going to be a 5. So this is just like close to 3. So this is accurate. Everything is all accurate. If you want for the vibes, you can just label the sketch. Nice. How many marks we get here for this? 5 marks. Nice. We love to all see it. So let us move on to D now. They said for 1 mark, determine this in terms of P. Well, this is you can remember, can you imagine, this is like a full-blown November exam, you see. So these kinds of questions, wow, man, people were having a party. So in the graph of f, whatever the equation is, you see this equation here, you might actually copy it like this, you know, because it doesn't matter if the 3 is in front or at the back, it's the same equation. So here they just said wherever x is, we need to throw in x plus p. So this is like f, right? And then this is going to be like x plus p. So what this means is you're going to have x plus p here, and then minus 2, and then plus 3 over there. Now the big idea here is we can just simplify, you see. Now fun enough, there's really nothing much you can do here. That's why this is just a 1 mark question, because I mean, like, I was also thinking to myself, wait, simplify what, bro? It's done already, and it's already in standard form. So yeah, for 1 mark here, they said, what effect would a negative value of p have on the graph sketched in C? Let's see. Okay, what would a negative value of p? Oh, well, this is another 1 mark question. So if you have p as a negative number, then it means that you would be moving the graph to the right, you see. So let's say here graph would be moved p units to the right, p units to the right. But then let's think about it. Would the graph, wait, p units to the right? I mean, this is one of those questions where it always seems like, you know, sometimes you'll be thinking, are they really trying to mess with my head or whatever? Nah, don't overthink it, you see. Remember, if p is a minus, then it means you're moving your graph to the right. If p was a negative, then, no, if p was a plus, then you'd be moving your graph to the left, you see. That's just a rule of thumb. So moving on. 3 marks here. They say determine the equation of the inverse of f. Well, determining the inverse is just swapping x and y, you see. So let us do it. Let us do it, man. So this is with the equation of f. When you perform inverse, x becomes y and y becomes x. It's kind of important for you to mention these kinds of things, you know, and write them down and stuff like that. So y here becomes x, and then x there becomes y, and then let's make y the subject of the formula. So this 3 has to come over first, and then we gotta be careful here. So we want to get y alone, you see. So this is, I'm going to show you something that you can always do when you're working with fractions, and this is something that is 100% valid. This is a fraction, this is a fraction. You want to make y the subject of the formula, but y is at the denominator down here. So the easy thing for you to do is to flip both fractions, you see. Flip this over, you can have 1 at the top and then x minus 3 at the bottom. Flip this over, you're gonna have y minus 2 here and then minus 4 at the bottom. And then making y the subject of the formula, here you can just multiply by -4 on both sides. So it's like -4 here, -4 here. You're gonna have -4x minus 3. This cancels that. You're gonna have y minus 2, and then that goes over, so you're gonna end up with -4x minus 3, and then plus the 2 there, equal to y. You see, they say you have to write it in the form that. So here you have to say, therefore the inverse is -4x minus 3 plus 2. Whew, looks good, eh? It look good. We love to see how it looks. I don't even know why I'm saying that the way I'm saying it, but I've just said it, so it's too late now, you know. It's too late. It's too late. I apologize. It's too late. Yeah, I feel like my answer is just crazy weird, but I wonder why my answer feels crazy weird, but it's too late. I apologize. Let me just actually double check my answer, you know, because I don't want to do the wrong thing. I don't want to do the wrong thing. So let me just check here nicely. Did I swap x and y? X and then y? Yeah, let me look at this a bit longer, because it doesn't look very, 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 you know what I'm saying? It like, why the subject of the, yeah, this looks fine. I mean, like, whichever way, this is fine. Anyways, so this being in this format, which is the best format to have, it's easier for you to determine the domain, because when you determine the domain, you just have to look at the x asymptote. So here you're just gonna say x is an element of R, but then x is not equal to -3. The other thing is the domain of your inverse is the range of the original one. So if you look at the original one, you see the range of the original one is just y is an element of R, but then y is not going to be equal to +3. That's why the domain is the way it is here. But the only thing is, wait a minute, why is it a negative? Oh, no, a +3, because the asymptote is at +3. And I think the best thing about what I've been saying now is because saying what I said also helped me to realize that I had made a mistake here. Because remember, the asymptote is at +3. That's the asymptote of the inverse. So we said the domain of the inverse is the range of the original one. So if you look at the range of the original one here, the range is just y is equal to, I mean, y is an element of R, but then y is not equal to 3. That's why for the domain of the inverse, we just say x is an element of R, but then x is not equal to +3. So knowing all these kinds of things that I've said now, you know, it helps you to also check your answers. Moving on. Question number 4. it says the third term of a geometry. So with questions like these, yeah, I always prefer just reading them while jotting down information. For example, here, the third term of a geometric series is 7. So a geometric series. So remember, T7 is no. Third term, that's T3, bro. T3 is 7. Apart from you just writing T3 7, remember, you need to know that a geometric series or a sequence is always in this format. You have A, the next term is just AR. The next one is just AR squared, and then AR cubed, going on and on and on until AR to the power of n. Now, the key thing to remember is, you see, this is T1, T2, T3, T4. So what's essential for you to know is, if this is T3, you need to know that this is how you need to write it out if you don't have a number for it, or if you're going to be referring to it. So T3 is equal to 7. So the easiest thing for you to write down here is just a to the power of r squared is equal to 7. And then they said here, the sixth term is equal to this. So this is going to be AR to the power of 5 is equal to negative 2401. And then they say determine the first term and the common ratio. You see, you have to determine A and R. And let's see, it's a basic 5-mark question because A and R can be worked out simultaneously. So here, let's get a value for A. A is just equal to 7 over r squared. Let's throw A in there. So this is 7 over r squared. The whole thing multiplied by r to the power 5. This is negative 2401. Here, you're dividing, right? So you have to subtract your exponents. 5 minus 2, that's going to give you a 3. Negative 2401. So divided by 7 here, well, who knows what that is, doesn't matter really. But then here now you have to cube root both sides, you see. Cube root this, cube root this. Remember, if it's a cube root, it doesn't matter if the value down there is a negative. It will still work out. You see, the only thing with being a negative, it won't work out for like if you're square rooting. So here your value of r is gonna come out as a negative, or what am I even doing? It's gonna come out as a negative 7. So here you have negative 7 in the calculator. So here you're gonna have, therefore, A is equal to r, and then negative 7 squared is like 49. So 7 over 49, which is like 1 over 7. Wow, man, such an easy question, right? Like, I know, right? I know, like, oh my goodness. So anyways, here it says the diagram below shows a pattern that is being formed as it progresses from figure 1 to figure 4. Yeah. Let's not lie, ne? This diagram, it doesn't look like there's any pattern or whatever. It just looks so weird. But let's see what this says. It says show that the number of circles in the pattern forms a quadratic sequence. Oh, okay. At least we're just dealing with the circles. So let's see. Let's draw out the thingy. It's like how many marks? I didn't put a mark allocation. Man. So let's just see 3 circles, ne? Then the next one is like 3, 4, 5, 6, 7. There's like 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wow, getting marks for counting. What a wow. This is like 4 plus 9. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. You see, I was about to do some funny shandies there, like be all mathematical. I was like, Baba, count. Use your fingers. Count. And I forgot what number. Shucks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Yo, I'd literally forgotten this 27. Because the boy was just talking too much, right? Anyways, first difference here, 7 minus 3, that's a 4. 15 minus 7, that's like 8, right? And then 27 minus this, that's like I don't know, it's like 15, like 12 or something. Is it really? Well, the easiest thing to do is like 8 minus 4 is like a 4. So here this also needs to be a 4. So 8 plus 4, this should be like, I don't know, 12. Yeah, because 27 minus 15 is 12. This is how you have shown that it is a quadratic number pattern, you see. This is probably like a 1 mark question, like legit, or 2 marks. But, you know, it doesn't matter really, because this is basically how you would show that that is a quadratic number pattern. So this question, let us move on to the next one. It says determine the formula for the nth term. Wow, man, this paper was so easy. Yo. So if you want to download this paper, you can just click the link in the description and then you will get the paper. So here 2a is equal to 4, 3a plus b is equal to the second 4 up there, and then I'll just do a plus b plus c afterwards. So here a, here if you divide by 2, a is going to be a 2, and then here if you throw 2 in there, it's going to be like 3 with a 2 there, and then you have 6 plus b is equal to 4. And then what is 4 minus 6? 4 minus 6 is like negative 2. So you have a and b, right? Remember, a plus b plus c is equal to the first term. Because let me actually write it here so that people don't get confused. You know, the one down here, this is equal to 2a. The one here, this is equal to 3a plus b. The one here, this is like a plus b plus c. Whew, moving on. Let's see. This is equal to what? Equal to 3, right? So a is a 2, b is like a negative 2, c is what we're working out. This is like c is a 3. So here we can say, therefore, what is tn? Highball. Tn. Igupi tn. Put pink there. So this is like tn is equal to, what is an squared? Highball. I got a already, most it's 2. What is b? B is like negative 2. What is c? C is like a positive 3. Nice. Let's just test our answer. So let's see if we put a 3 in here. 3 squared is like 9. 9 times 2 is like 18. 18 minus 6, that's like 12. 12 plus 3, that's 15. Nice. The mental math is like on fleek. Oh, I forgot to do one thing. I forgot to put the course website. Oh my goodness. Courses.bright young. Oh, yucks, man. Young brains.co.za. Me, I'm forgetting to plug the website. Ay. It is what it is, man. It is what it is. Anyways, yeah, this is where you can get the online courses. So yeah, do the most. That was weird. Do the most. That's saying, it's like, my guy, so cringe-worthy, man. Question 5 says, in the diagram below, the graphs of f of x is equal to 2p to the power of x plus q, and the log graph are given. Yo, yawning is so good. Excuse me though. But anyways, it says, yeah, this is clearly an exponential graph. Like, you know, it's an exponential graph because x is on the exponent position, you see. That's what you need to keep in mind. And then it says here, these are given, and then it says, note, O represents the origin. Yes, duh. O does represent the origin. So, all that being said, it says here, the graphs have a common x-intercept at C. Yes, thank you very much. And then it says here, the graph of f has a y-intercept at D. Okay. Oh, excuse me, Yamar. I wonder if yawning is as I know, like when you're seeing someone yawn, it's easy to start yawning as well. I wonder if it's the same when you're like hearing them yawn, huh? I wonder, man. I wonder. I guess you can just let me know in the comments, right? Yeah, I don't know. I'm stop getting distracted. It says the asymptote of f and the graph of g, okay, both pass through a. Where is a? Oh, okay. Let's read that again. The asymptote of f and the graph of g. Hi, but how? The graph of g. This doesn't make sense now. The asymptote of f and the graph of. Oh, okay. The asymptote of f, right, passes through a, and then the graph of g also passes through a, you see. So they have given us the equation of the asymptote here. It is just y is equal to -1, because the y value here is -1. They also just said the graph of g passes through that same point. Remember, this pink asymptote is not the asymptote of the graph of g. It's just an asymptote for the graph of f. Here it says EBA. Where is EBA? EBA is a straight line perpendicular to the x-axis. Oh, excuse me. Yo, okay, I told you. Yo, I'm sorry. I think I mentioned it in the beginning, but I'm like recording this kind of late, you know, because the grind never stops, man. The grind doesn't stop. Oh, no, I'm not crying. I just promised someone that I was going to do this paper today, so kind of need to stick to my word, you know, because word is bond. So this is perpendicular to the line EBA. And then what else they say here? That's everything given. Okay, so it looks like an okay question. Let's see. For 2 marks, determine the value of t here. So this should be easy, because you have a coordinate that the graph of g passes through. The x value is a 2. The y value is a -1. So this is how you can easily work out a value for t. Because remember, in this format, you always need to keep in mind that this is the exponent, this is the base. You see, exponent, base, and then this is the value on its own. So work out a value for t here. You have 1 over t is equal to 2 over 1, because you see any number on its own is like over 1. And then obviously, if you want to get t on its own, you can just flip this, and then you can have t, and then you can flip the other side also, and then you'll also have t. You see, like here, flip this over, you're gonna end up with this flipped over gives you t over 1, this flipped over gives you 1 over t. You see, therefore t is equal to half. That's the way. I like it. You could have cross multiplied and then divided by 2. It doesn't matter. You still end up at the same answer. But remember, we're trying to showcase different ways to do certain things. You see, like here, flipping this and flipping this, you'll be good. For 1 mark here, write down the coordinates of C. Where is the coordinate of C? C is the point of C is the x-intercept of the graph of G. So y is a 0 here in the graph of G. So the graph of G, we know that g of x, we worked it out to be log a half with x here. So in our case, we want y to be a 0, because we want c. So here log half with x. And then now we can even practice again, like what we had said in the beginning. This is the exponent, this is the base. So you have a half to the power of 0 equal to x. Therefore, x is equal to 1, because anything to the power of 0 is a 1. So if x is a 1, then it means that c is 1 coordinate 0. Because you see, okay, that's not funny. But, I mean, it is a c, you know, like, you know, it's not me, never mind. Let us move on. Determine the value of p, showing all workings. Value of p. So the value of p is in this graph now. So technically, remember, f here, its asymptote was a -1. So automatically the graph of f we have the asymptote, you see. So it's like p to the power of x, and then asymptote is a positive. It's a -1. So here's going to be -1. Because remember the standard formula for an exponential graph. This value on the far right will always be our asymptote. So getting a value of p, we need a point that the graph of f passes through, and f passes through c. You see? So the graph of f, we said f of x is equal to p 2 to the power of 2 with p to the power of x, and then minus what? Minus what, bro? Minus 1, right? So this is like minus 1. And then here let's throw in a point that the graph passes through, which is c. C passes through. C is a point that this graph passes through. So the y value of c is a 0, while the x value is like a 1, right? So getting p here, it's quite simple. The 1 can go over. It's going to be like 1 as a positive. Then this is 2 to the power of 2p to the power of 1. And then dividing by 2 on both sides, you see. It's going to give you a half. It's just a coincidence that p is a half and that t is also a half. Like legit. Nothing but a coincidence. Getting the coordinate of d. How we going to get the coordinate of d? Well, yeah, this paper, yo, just going through it, I'm like, hey, these guys had a nice paper, yo. Like, yo. This is just the y-intercept, meaning x is a 0 in the graph of f. So in the graph of f, which is fully done now, this would be like f of x is equal to 2 times a half to the power of x minus 1. Here, if you get the coordinates of d, remember, for d, x is a 0. You see, x is a 0. So what you gonna do? What you gonna do when they come for you? X is a 0, so x is a 0 there. So it's gonna be like y, x is a 0. And then it's like 2, 1 and 2, x is a 0 minus 1. Anything to the power of 0 is a 1. So this is like 2 times 1, which is 2. And then minus 1, that's just 1. So this is a coordinate, you see. Therefore, d, x value is a 0, y value is a 1. It looks like these graphs are like inverses of each other. That's what it looks like. Like legit, man. Like legit. That's what we are seeing here. Because look, this is the y-intercept. This is the x-intercept, right? And then this is like the y-intercept of the other graph. Like, it just looks that way. It looks as though these are inverses of each other. No, are they? No, they're not, because they would only be inverses of each other if they were a reflection of each other about the line y is equal to x. So remember here, this green line is the line y is equal to x. So if these graphs were inverses of each other, there would need to be like a mirror image on the left here and on the right here. So just be careful of things like that. They are not necessarily inverses of each other, but they are reflections of each other in some way because of the way this looks. It looks like they're reflections of each other about this line over here. Let me draw another color. Let me use another color. It looks like these are reflections of each other about this line over here, because remember, this is 1 and this is like -1. So it looks as though these graphs are a reflection of each other about this red line, because see, on the red line towards the left, it's exactly the same as what it is down there. So let's carry on and see how that plays out. Calculate the length of AB. Well, AB, the good news about B and A is that you just have to compare their two y values, because the x value here is a 2, the x value here is also a 2. So obviously you need to think to yourself that the x value of B is a 2. So for you to get the y value of B, you can just throw its x value into the equation of f. So into the equation of f, let's throw an x value of 2. So in the equation of f, To start off, let's throw an x value of 2 so that we can get the y value of b. So this is like a quarter times 2, or it's like a half. And then we are getting a y value of like negative a half. You see, you can just put all this into calc, because remember, this is just going to be a quarter. A quarter times 2 is a half. A half minus 1 is negative a half. So now you know that the x value of b is just a negative a half. So obviously, if this is like negative 1 and this is like negative a half, the distance here is just like half a unit, you know, because I mean, like, that's just how it is, you see. So here you can literally just say, therefore AB is equal to half a unit. Because it's just comparing the distances, you see. Half a unit, this is like half a unit downwards, and this is like negative 1. So obviously, I mean, negative 1 and negative a half, the distance here is just half. Woo! Wow, this guy did a nice paper. Yo, write down the range of f. Where is f? You have to look at f nicely. F, we can see here, this is its range. I mean, this is its asymptote. You see the graph of f, it doesn't touch that yellow line. So we can say that the graph of f is everywhere up, going up, you see. So the range here, y has to be bigger than negative 1. You excuse me, did I just burp? I did. Oh, I'm sorry. Really though, no, excuse me, not I'm sorry. Like, that doesn't make any sense. What am I saying? Excusez-moi, I get khabab, but khabab? Bro, what the hell? Never mind. I think I should just keep quiet before I start embarrassing myself. So, question number 6. What does it say? It's for 5 marks, first principles. Okay. So if I'm like move around and you hear like a farting sound, I'm not farting. I'm sitting on leather. So if I like squeak around, it might go like creak. So don't be like, Levi, time step number 1, something. Did you just fart there? No, I had her move on the seat, and then the seat and my pants, you know, had go, and then the sound that I had gemaak, it was not the biggest snack. So yeah, it is what it is. Anyways, what is this? If you're gonna use first principles to simplify or to differentiate, you have to remember that the first principles formula is on your formula sheet. So this is something that you don't have to cram. You just have to, you know, just get it from the formula sheet. Why didn't I give myself a whole page? Me. I literally just write one thing down and I'm already seeing that here I'm gonna need more space. But this boy didn't give himself space, man. Like, just sad, bro. But anyways, let's see. Wherever x is, to start off now, you want to get an expression for this first and then throw it into your equation. So let's see. This just means that wherever you see x, just throw x plus h in there in your equation of f, you see. So here we're going to have 1 minus 2x plus h, and then here it's like x plus h, the whole thing squared. And it's like 1 minus 2x minus 2h, and then here plus x squared plus 2xh plus h squared. Whew, here, this is as simple as it gets. You see, you cannot do anything to this expression. It's already in its simplest form. So that's why here, oh no, I forgot the lim thing. Yo, I'm pretty sure you're looking at it and you're like, bro, you left out the lim. And I'm out here like, yeah, I don't need the formula sheet. But then, I wrote it wrong. And you may be thinking, will you be penalized if you don't have the lim thing? Yeah, most def, man, most definitely. So just have the lim thing there, because the lim thing is what allows you to throw in a 0 where h is at the end. Lim h goes to 0. Here we worked this out already. And the beauty of the tabletta is that I can means the beauty of whatever this is. Paste please, paste of using the digital what can just copy and paste things here. So subtracting f means the signs just need to change here, or just use brackets. So subtracting f here, we're gonna have a -1 there, gonna have a plus 2x there, we're gonna have a -x squared there. Don't forget to do that, otherwise you will cry. So the bottom part here, there's just h. So here, if you have done what you've done now, if what you're doing is correct, then this would need to cancel that, this would need to cancel that, this would need to cancel that. If you don't find yourself doing any cancelling, you have done something wrong 100%. So this is just going to be -2h plus 2xh plus h squared, the whole thing over h, and then you just want to take out h as a common factor. So taking out h as a common factor, what do you have? It's like h there, -2, 2x, and then h here. There we go. So here, let me put the pink. This cancels that. You're gonna have lim h goes to 0. It's like -2 plus 2x plus h. Now you can throw 0 in there. So here, therefore, f of x with the, what do they call it, an accent, is gonna be -2 plus 2x. You see, hence the lim is gone because you threw 0 where h is. So to test out your answer, you can just see what this would look like if you were to differentiate it without first principles. If you were to use the power rule, this would be like, this would fall away, then you would just have a -2 here with 2x over there. So you see, -2 here with 2x over there. Nice. Yo, this is so easy. What is this? Differentiating this, get dy over dx means we need to differentiate. So here, dy over dx, this is already in standard form. So 10 times 1, and then removing 1 from the exponent. Here, 1 times 10 is a 10, and then 1 minus 1 is a 0. So you're done, you see, because x to the power of 0 is a 1. So you don't have to write the 1 here. We have differentiated. How many marks? 2, as you can see, because it's an easy question. Oh, differentiating this. Oh, let me see. Yeah, because both of them you have to differentiate. You have to get dy over dx. Here, you see, I'm writing y here because I have not yet differentiated. I'm just simplifying. The first step of simplifying, you want to have this as the denominator. You also want to have this as the denominator. And then you want to take this up. So this is like 5 with x to the power of -3. Because when you take this up, this becomes a negative. Here, you can do the same. You can just have this there and then this negative. You see, I'm trying to do one thing at a time. You see, I'm just simplifying. That's why I keep writing a y in front here. So here, we're almost there in terms of simplifying, because here, you just want to realize that there is a tiny 2 here and a tiny 1. So when you simplify before you can use the power rule, this 2 goes under the 1 there, meaning you're going to have x with 1 over 2 times x to the power of 3, you see. And then simplifying some more, you're going to have this, your bases are the same and you're multiplying. So you add your exponents, you see. So 3 plus a half. What is 3 plus a half as a fraction? Ish, isn't it like 7 over 2 or something? Yeah, I think it is, 7 over 2. Anyways, now you can differentiate. You see, that's where the 4 marks is coming from. Just simplifying, you see, because the rest is just easy. Now here you can put dy over dx, because 3 times 5 is like negative 3 times 5 is -15, and the -3 minus 1, what is that now? -3 minus 1, that's like -4. And then here, 7 times 1 is just 7 over 2, and then subtracting 1 from there, you're gonna have like 5/2. Whew, very nice, very nice. We are love to RC it. Anyways, let us move on. What you moving on to now? We're moving on to bigger and brighter things, man. Bigger and brighter things. But I think before we move on, let me just double check these answers. Let me just see here. So this here, it doesn't look like anything is wrong. Just look at it nicely. -15. Yada, yada, yada. Everything looks all nice and dandy. Yeah, let's see here. Other stuff looks okay. Yeah, I mean, this question is fine, you know. -7. I think I'm supposed to subtract. Yeah, wait a minute. What is like negative? Yeah, I feel like this one. Oh, yeah. 5/2. Because it's like, I have to take it up, so I have to put a minus. If you, oh, yeah, that's why I made the mistake. Yeah. That's why I kept looking at it and kept thinking, this, remember, this went up, so it has to become a negative. And then here, I forgot to put a negative here. So if your base is the same, you add the exponents, right? Meaning that this is going to be 5/2. And then, if this is like 5/2, it means that this is also going to be 5/2. And then 5/2 minus 1, that's going to give you the 3/2. You're not. No, but it's a negative, bro. It's a negative. It's a negative thingy. This is gonna be a negative. This is gonna be a negative. And then this is gonna be a 7. Because you see your base is the same, so you add the exponent. So -3 plus a half gives you -2.5, which is like -5/2. And then going on and on. So it says good to check your answers, because you see, if you don't check your answers, you're going to cry, man. And crying is not good, eh? Crying is not good. But anyways, let's move on. Where is the next question? Where is it? Aibo. I left the whole page open. Yeah, ne? Anyways, moving on. Section B. Question 7. Please tell me I did question 6 just now. Yo, I'm feeling like it. Anyways, what is happening here? It says, in the diagram below, I don't need to see this part. In the diagram below, the graph of what, my guy? I'm trying to make sure this thing is, okay, this is perfect. In the graph below, the graph of the cubic function is shown, O represents the origin. Where's the origin? Well, O represents the origin is what they said. Then they said R and S represent the x coordinates of 2 of the x-intercepts of the graph. Excuse me. I have to read this again. Where is R? R is here. S is here. So it says R and S represent the x coordinates of 2 of the x-intercepts. Yes, only 2 of them. You see, because the other one is not mentioned. Then they said A and B represent the stationary points. Yes, which are the turning points. So up here we know that the gradient is a 0. Down here we know that the gradient is also a 0. Like, hello, that's how it is. And then it says here P and Q. Where is P and Q? P and Q are the y values of the respective stationary points. You see, P represents the highest. No. P represents the y value of the maximum turning point. Let's call it max. And then Q here represents the minimum turning point. Let's call it min. There we go. And then it says for which values of x is the gradient smaller than 0. You see, this here, remember, first derivative means gradient. You see, this question is literally asking you, where does this graph have a gradient that is a negative? And a graph will always have a gradient that is a negative if the y values are decreasing as you're moving from left to right. So if you're looking at the image, oh, I'm sure it's pretty annoying sometimes, and it's like you're just talking and all of a sudden someone is yawning. It's like, my guy, yawning out of nowhere. So if you're looking at the image from left to right, if you see that your y values are going down, those are all parts where you have a negative gradient. You see, negative gradient. This part, you see your graph is going upwards. So these are all parts where you have a positive gradient. And then from here, you see your y values are going downwards again. So, hey, come on, man, come on. Your y values are, it's so hard. As your x values are increasing, your y values are decreasing. You see, that's how you know you have a negative gradient. So, x value here is a -4, x value here is a 1. You see, those x values are important because that's why they're asking for which values of x is the gradient smaller than 0. The gradient is smaller than 0 on the left of -4. So here we have to say x is smaller than -4 or x is bigger than 1, like that. That's how this is just a 2-mark question. For 3 marks here, they said draw a graph or draw a sketch of on the grid of the first derivative, indicating only the x-intercepts of the graph. So the idea here is, this is also something mentioned in like the applications of calculus playlist on the channel, on the main channel, Bright Young Brains, because remember you're watching this on the second channel. The main channel is called Bright Young Brains on YouTube, and the website Bright Young Brains, or rather the website courses, man, write it nicely, my guy, write it nicely, plug yourself nicely, courses.bright, so much writing, is it gonna fit? Bright Young brains.co.za. Oh man, .co.za, come on, man. .co.za. This is where you can get the online courses. And basically what you wanna know is, this is a negative cubic function. The first derivative of a negative cubic function is going to be a frowning parabola. You see, this is what its first derivative is going to look like. So now that we know that, you always have to remember that the turning points always represent the x-intercepts, because remember, the y values of your first derivative are always going to be the gradients of your original graph. So we know that the gradient here is a 0, so that's why the y value here is a 0. And then we know that the gradient here is a 0, that's why the y value here is a 0. And then the point of inflection is going to represent your turning point. So between -4 and 1, we know that what is in the middle of that, let's see here, -4 plus 1 divided by 2, that's like what? -3/2. That's like -1.5. Somewhere here, -3/2. This is where the turning point is, somewhere over there. We don't know what the y value is. They say we don't have to worry about it. As a matter of fact, this is not even important, because they just say they want you to give the x-intercepts of the graph. So you do that and you move on, If they didn't ask for it, don't do it, because what if you're wrong, And then now you've put in unnecessary information, then you end up losing marks. So this is the first derivative. We have labeled 1 because of this point and -4 because of that point. There we go. 3 marks. What do you say here? It says, we need here, it says that the equation f of x minus k is equal to 0 has only one real root. So meaning it has like one x-intercept. One x-intercept. For which values, what? Okay, it says here, the equation f of x minus k is equal to 0 has only one real root. What are all the possible values of k? So this kind of a question is the kind of a question where the functions and graphs course will definitely help out, because if you look at where k is, k moves the graph up or down. You see, moves graph up or down. So let's say he moves graph upwards. It would move your graph upwards if k was a negative. Okay, let me just here moves graph up or down. Now to add more information, you see how there's a negative here. This is important. Because there's a negative there, it just means that if k is a negative, then it means your graph would be moving upwards. You see, because a negative and a negative would give you a plus, meaning your graph would be going upwards. If k was a plus, it means that your graph would be moving downwards, you see. So anyways, for this graph to have one real root, this graph here, you have to remember that the distance, you moving it upwards, right? You have to move it upwards more than 4 units up. So you moving it 4 units up, you're going to say k needs to be smaller than -4. Because if k, this is one of your answers, because if k is smaller than -4, it means that you're putting numbers here that are smaller than -4, meaning a negative times a negative will give you a plus, meaning you'll have moved your graph more than 4 units upwards. And then anytime you move your graph more than 4 units upwards, your graph will only have one x-intercept. And let me show you as an image here. Let me just show it to you real quick. Because for example, if you look at, let me just complete drawing this thing here so that I can move of this image. Let me show you. You see, like the way it is here, rather the way it is right now. This graph, hey, what am I doing, man? I don't know, thing in the line. Do this, here we go. If you move it more than 4 units upwards, you see, this is exactly 4 units. This is more than 4 units upwards. If you move it more than 4 units upwards, you see it has one root. It has one solution. And also, if you look at the other turning point, if you move this graph more than 1 unit downwards, you see, if you move it more than 1 unit downwards, you see, it's only going to be having one x-intercept, you see. So those are the only 2 scenarios where your graph has one real root. So this is the first answer. The other one, we said that you have to move your graph downwards more than 1 unit. So we said here, moving your graph down, your value has to be a plus. So here we have to say k has to be bigger than 1. You see, because if k is a number that is bigger than 1, it means that you're moving your graph more than 1 unit downwards. And then if you move your graph more than 1 unit downwards, it will only have one x-intercept. Oh yeah, so yeah, I clearly made a mistake here because I was looking at the x values and I'm forgetting it's x values, not like y values. But the idea is still the same, you see. The distance here is technically going to be q units, and the distance here is technically going to be p units. So I just need to replace 1 with a p because I need to be talking about y values, and then I just need to replace the 4 with the q. Let's see here, 4 with the q, and then let me just re-explain what I was doing. So remember, the idea here was we just have to deal with the distance here, and we just have to deal with the distance over there. Now the distance over here is like q units, so the graph here has to be moved upwards at least q units, and then here the graph has to be moved downwards at least p units. So yeah, I had mixed up the p value, I had mixed up the y values and the x values, but the analogy is still the same. You see, for here they're saying for the equation this has one real root, and we said here wherever k is, it just moves the graph up or down, and it all depends on the y values of the turning points. I was busy using this and using that instead of using p and Q, because you see P goes with the B value there, the Y value of B. Q goes with the Y value of A, which is basically all you just need to use instead of the X values, you see, because the X values, you don't use them for this kind of a question. Let us move on. Anyways, determine the values of X for which the given graph of F is concave down. Wow, man. So in terms of concavity, you always deal with the point of inflection, you see. The point of inflection is the point that is exactly in the middle of your two turning points. Or rather, for this kind of equation, you just need the X value of the point of inflection, of which we mentioned that the X value of the point of inflection, let's say here X value of the point of inflection. So the X value of the point of inflection, is this one, the value that is right in the middle of your two X values, you see. 2x turning points. The one turning point is at 1, the other one is at positive 4. So negative 4. So the point of inflection is at this point. Now what we know is the part that is concave down is the side that will be frowning. You know, the side that's frowning, that's the side that's concave down. So here, the part that's frowning is where X is bigger than negative 3 over 2. So that's why this is just a 2-mark question. Because it is not, it's not crazy, you know? It's not crazy at all. Like, hello? Anyways, moving on to question number 8. It says, consider the word Olympiad. How many 6-letter word arrangements can be made if the letters may be repeated? Well, if letters may be repeated, then it's like 6-letter words. So it's like 1, 2, 3, 4, 5, 6. So you have 6 places where letters can go. Now, because letters can be repeated, it means that you have 1, 2, 3, 4, 5, 6, 7, 8 options, right? So in the first slot here, you have 8 options. The moment you put 1 here, you still have 8 options here. Same here. Same here. Oh, look at how I'm writing my 8s. I never write my 8s like that. Like, it even felt weird doing it. I have to like redo it because it's like, man. Nah, fam. What was that? Let me stay abnormal and write my 8s like this. Y'all can do your 8s the way you do them. It's fine. So all these 8s here, they're multiplied by each other. It is just 8 to the power of 6. If you want to give a final answer, feel free to do that. Like, you can just use the calculator, you know. Anyways, moving on. If you noticed from the previous question, I had like made a mistake, and obviously I found out the mistake after I had checked now. So yeah, checking is gooder. Anyways, for 2 marks here, it says how many 6-letter word arrangements can be made if the letters may not be repeated. Well, this one is easy because you have 6 slots to put letters and you have 8 to choose from. So you put 1 here. Oh, I keep doing that. It feels so weird. When you let me start again. Remember, you have 8 options for this one place here. 8 letters to choose from. The moment you choose 1, you only have 7 left for this option. The moment you choose 1 more, you only have 6 options left here, and then you only have 5, and then you only have 4 options, and then you only have 3 options. You see, this is the number of options that you have for a 6-letter word where letters may not be repeated. Now, here we can clearly see that your answer in the calculator is just going to be 20,160. Now, let's see here. It says a box contains, what does the box contain now? A box contains 3 40-watt bulbs. Okay. This is interesting. A box contains 3 40-watt bulbs, 5 60-watt bulbs. The word bulbs is so weird, eh? And 700-watt bulbs. And then it says the 2 bulbs are taken out at random and at the same time from the box. So when they say stuff like take out at random and at the same time, just remember that even though they're saying that these bulbs are taken out at the same time, when you represent it in, for example, a tree diagram here, you're going to need to show a scenario where the first one gets taken out and then the second one afterwards, because one way or the other, that's how realistically speaking it plays out. So here they say represent this information on a tree diagram. So 2 bulbs being taken out. It's quite simple. So here, when you take out the first bulb, you have to remember that when you take out the first bulb, you have 3 options: the 40, the 60, or the 100. You see, let's say here 40, 60, 100. You see the chances of you choosing the 40-watt bulb. Wait, let's see. A box contains 3 this, 5 this, so it's just one box, and then 2 of them are taken out from that same one box. So the 40-watt bulbs, you have 3 bulbs out of let's see, 3 plus 7, that's 10, plus 5, that's 15. And then 60-watt bulbs, you have like 5 of them out of 15. 100-watt bulbs, you have like 7 of them out of out of 15. And then what else is this? Here you have like 1, 2. Whoa. Let me create myself some space, because this is the scenario when you take out the first bulb. You see, you're either gonna take out this one, or this one. Now when you take out the second bulb, remember, if you had chosen this one, then it means that you still just have 3 options to choose from. Here you still just have 3 options to choose from. Here you still just have 3 options to choose from. If you had chosen, depending on whatever you choose first, it doesn't affect what you're going to choose after. So for example, here you can either choose a 40 again, a 60-watt bulb, or a 100. Here you're either going to choose a 40 again, 40 only, 60 again, or a 100. Here you're going to either choose a 100 again, a 60, or a 40. You see, this tree diagram shows what could potentially happen when you take out a bulb twice, or when you take out 2 bulbs at the same time. Remember, this whole thing of you taking out at the same time is just the wording, because realistically speaking, even if you take out 2, if you put in your hand and you hold 2 balls at the same time, you clearly held one of them first. You see, if you hold one of the bulbs, if you hold 2 bulbs, like, you held one of them first, even though it was like a microsecond apart, you still held one of them first. Hence why the scenarios are drawn out like this. So here you have to remember, you would have taken out 1 40 watt bulb, so here you'll only have 2 of them left, so here all 5 60-watt bulbs you have 14 left because you took out 1. Here all 5 bulbs are still there, so it's like 5 over 14. Here all 7 of them are still there, 7 over 14. And then here all 3 are still there, and then here 4 are left, and then here all 7 are still there. Here all 3 are still there. Here all 5 are still there. Oh, why did I put 15 there? It's supposed to be 14, bro. Come on now. 3 and 14. And then this is like 5 and 14, my bro. This is like 6 and 14. So these kinds of tree diagrams, you definitely need to concentrate, because you can already imagine, man, like, this is where you can easily just flop, like, after doing so well, and then just flop at the end, like, The best thing I can recommend is, with the tree diagram, try and just complete it, because it will make the follow-up question so much easier. So this is like 40 and 40. So let's just put here 4, 4. And then let's just put here 4, 6, 40 and 60. Let's just put here 4, 1. Let's just put here 6, 4. And then 6, 6. 6 and 1 for 6 and 100. And then here 1 and 4 for 140. and then 160 here, let's put 1 and 6, and then 100 and 100, let's put 1 1. Anyways, so we already know that the outcomes here, they are different. You see, there's this scenario, this one going on, and the outcome here is just this value times that one, and then the outcome here is just this one times that, going on and on. You don't have to put all of them, you just have to eventually just put the ones you need. So this is good enough to get you 3 marks, this tree diagram, even if you didn't put like this here. So for 3 marks here, they said calculate the probability that let me see what let me choose a color already. Calculate the probability that the sum of the watts of the bulbs taken out is 160 watts. So you getting 160 watts. What happened here? Did I delete this by mistake? Haibo. No ways. What happened? That was just so weird, man. Like, creepy weird. I didn't even see me do this. Let's see. This is there. This is there. This is there. This here is like 6 4, 6 6, and 6 1. There's like 1 4, yada yada yada. So, anyways, they're saying what is the probability of you getting 160 watts as a combined watt from the bulbs that you pick? Well, you just have to circle whichever ones give you 160. So this gives you 160. This is also going to give you 160. Those are the only 2 options that give you 160, you see. So you have to be careful. So the probability of that happening is going to be this probability plus this probability. So this probability, you can see it's like 5 over 15 times 7 over 14. And then obviously you have to put this in your calculator. This in your calculator, in its simplest form, it is just going to be 5 over 30. No, this is not in its simplest form, bro. Come on now. In its simplest form, I think it's gonna be like, I don't know, 1 over 6, if I'm not mistaken. So that's for this one. The other one is just going to be 7 over 15 times 5 over 14. And then what is it gonna give you in the calculator? Yo, angazi mina got to use the calculator. Calculator, please help. Please help a lot. But whichever way, I mean, like, this really doesn't matter. Let me not even bother getting the answer here, because all we have to do is we have to take this and we have to add that. You see, that's all we have to do. So here, let's take this, copy it. Let me paste this over here. And then you have to plus this one. Plus this one. Let me copy this. Let's paste it over there. Paste. And then your final answer is your probability. Let's put all this in the calculator. Put all this in the calculator. Put all this in the calculator. What are you going to get in the calculator? Let's see here. In the calculator, we are getting there 1 over 3. Wow, that's quite interesting. That's quite a lot of, that's a high probability though. Like, yo, it doesn't even feel like it though. Wow, man. Let's see how many outcomes there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. Huh? No, it can't be 9, man. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 3, 6, 9. Yeah. Wow, that's kind of weird. It's like 2 out of 9. Okay, no, never mind. That's the answer. Anyways, so here 3 marks easy. The next question says for 4 marks, right? Maria decides to enter 2 different math Olympiads. 2 different of them. The probability that she wins one is 0.2, and the probability that she wins the other is 0.08. Okay, this is quite interesting. And then it says here, assuming that winning the different Olympiads are independent events. Independent events, you have to remember probability of A multiplied by the probability of B is equal to the probability of A and B. That's for independent events. Let's just put that down so that we know it. So it says here, yeah, assuming that winning the different Olympiads are independent events, determine the probability that she will win at least one of them. Wow. Yo, for 4 marks. Yeah. I even had to yawn first before thinking. Because normally with probability, I mean, a 4 mark question is not a joke, eh? It is not a joke. It is not a joke. So we have the probability. Okay, let's just read the question again. The probability that she wins one is 0.02, and the probability that she wins the other. Oh, this is winning one of them. This is winning the other one. Okay, so the probability of winning one of them, the first one, is 0.02. The probability of winning the other one, it is just 0.08. So technically speaking, let's think of it this way, right? I'm even thinking of a Venn diagram, really, because just thinking of, probability and stuff like that, a Venn diagram here might just do well, because look, this is going to, I'm thinking of this because of the probability online course. This is a probability of winning one of them. This is a probability of winning the other one. So the probability of winning one of them is 0.2. So what that means is, let me actually color code it for you. This 0.02, rather, this 0.02, it is representing this whole thing. You see, meaning the number here plus the number there should give you 0.02, because that's the probability of winning one of them. And then the probability of winning the other one is 0.08. You see, meaning that the probability here and there should give you 0.08. In the middle is the probability of winning both of them, which we can get from this formula over here. And I promise you, me being able to write this and even be thinking of a Venn diagram, it is purely because of the probability course on the course platform. So the link to the course platform is in the description. Anyways, probability of A here is just 0.02 multiplied by 0.08. You see, this is what gives you the probability of A and B, which is what's in the middle here, the probability of winning both of them. So I mean, it is a math Olympiad, so it's quite difficult. That's why these probabilities are low. In your calculator, this is just going to give you 0. Hey, calculator. I don't have a well, yeah, let's is it 0.16? I don't know, bro. Like, I ain't gonna take that chance. 0.02 in the calculator times 0.08. Yeah, you see, 0.0016. Yo, I was about to flop so nicely. Anyways, so with this being said, you can go ahead and throw in this number here. Actually, I don't even know how to put it in, but it's so tiny. I'll just put it in sideways, you see. And let me make this much smaller because this is important anyways. 0.0016. That's the probability of winning both of them. So now we can put in this probability and this probability, because remember, the orange one has to add up to 0.02. So 0.02 minus the value in the middle, which is 0.0016, that's going to give you 0.0184. And then on the other side, 0.08 minus the value in the middle, this is giving you 0.0784. 0.0784. Whoo-wee. Yes. Anyways, this is all good for 4 marks. We're almost there. Now they said here, determine the probability that she will win at least one of them. So winning at least one means she either wins A, this is the probability of winning A, and then this is the probability of winning B. So the probability that she wins at least one of them, it is basically going to be, well, whichever way, right? Her winning at least one of them means she either wins A, or she wins B, or she wins both. You see, that's the probability of winning at least one of them. You see, because winning at least one of them means that she could win one only, she could win both, or she could win the other one only. So we have to add up 1, 2, 3 values for us to see the probability of her winning at least one. So here we have to say this value plus this value plus the 0.0784. So here 0.00184 plus 0.0016 plus 0784. This is the probability of winning at least one of them. So let's see what that gives us. 0.00184. 00184. No. What am I doing? How? So far into the question and we're making silly mistakes. Oh, come on, bro. Come on now. 0.0184 plus 0.0016 plus 0.078 equals, that's like 0.0984. This is the probability of winning at least one of them, because the probability of winning at least one of them means the probability of winning either this one alone or this one alone, or winning both of them. You see, that's the probability of winning at least one. So this question, you can clearly see it's quite intricate, because even like the thought of drawing the tree diagram, you see, that's like super brain power thinking capachondis, you see. And I give 100% credit to the probability course, like legit. Anyways, I think we can move on to the next question now. Question number 9. What does it say? It says the Maputo Katembe Twin Tower Bridge extends over the Maputo Bay. Okay. Then it says the diagram shows a representation of a suspension cable above the mean water level. Oh, okay, I get it now. And then it says here, the height h in meters of the suspension cable at a horizontal distance x meters from the base of the left tower can be modeled by this function. So what they mean is this hyperbola here, right, is a representation of like that cable over there. Now they said that the distance between, it says here the horizontal distance x meters from the base of the left tower can be represented by this function. So whichever way, right, I know this kind of a question, you know, you're hearing a bridge, you're hearing this and that. Just focus on the fact that you have a hyperbola, you have a parabola which has this equation. This equation is in completed square format, meaning A and B give you your turning points. And then they said here the midpoint between the two towers and the suspension cables are 190 meters above the mean water level. So it says here again the midpoint between the two towers. So this is tower 1, tower number 2. The midpoint is somewhere here, and they said here this is like 190 meters, right? According to this, 190 meters above the water, above the mean water level, so the average water level. And then it says that the distance between the towers is like 1,450 meters, and the towers are both about 315 meters tall. And then it says here, measured, yeah, they're both this height measured from the mean water level, which is our x-axis in this sketch. And then all that being said, they said here a hydrometer, which let's say here shown as A in the diagram below. Okay, there's a hydrometer here. There's a hydrometer here to measure the humidity. And then they said it is placed on the cable at a height of 210 meters above the mean water level. Okay, fine. All we can do is to focus on how this is just a parabola. The rest is just, honestly speaking, low-key pure nonsense. It says write down the values of A and B. A and B, remember, it's going to be the turning point. The x value of the turning point, the y value of the turning point. X value of the turning point is in between 1450. So because this is going to be 0, this is going to be 1450. In the middle is the x value. So here, 1450 divided by 2, what does that give us? Doesn't that give us like, I don't know, 725, 725, my bro. Yeah, it's 725. Yeah, that's the middle. And then the y value, you see, it's like 190 above the x-axis. So here we can then say this is A, right? And then B, when it's like 190. There we go. So that's A and B. And then here it says calculate the horizontal distance of the hydrometer from the left tower. Okay, the horizontal distance, meaning we have to calculate this distance here, because horizontal means from left to right. So the good news is you just want the x value of A. Getting the x value of A, getting the x value of A, yeah, that doesn't look like it is going to be difficult. We basically just need to get the equation of, excuse me. Let's see if there's a point where they're going to ask us for K. I don't think so. Well, what is the next question there? So, yeah, this one is quite easy. Let's just get K first. And then just throw in this point in the equation. So, with our equation here, let's see. H of x is... H of x is equal to K, x minus A, and then plus B squared. We have A and B already. We worked it out to be, what did we work it out to be? A, we got it to be like 725, so it's like negative 725 over here. B, what you get for B? What do we get again? I forgot. It was like 190, like it was 190. There we go. Getting K, we need a coordinate that the graph passes through. And we have one right over here, you see. The x value there is like 1450. The y value there is like 315, you see. So let's throw those into our equation, because we want to then get a value for K and then use that equation to then get the x value of A, because as long as we get the x value of A, we get that distance of all day. Fantastic. So y value here, we said it was 315. Was it 315? Yes, maybe it was 315. Just write this nicely here. 315 is equal to K. X here was like 15. So here, don't be surprised getting like these big numbers, because I'm like, hello, you are working with meters and stuff like that here. So don't panic. So here K is equal to this 50 minus 725 squared. Let's divide that on both sides. I don't even know why I'm doing all this. No, I don't know. I'm like taking. What am I saying? I don't even know. I feel like I should have. I'm sure you think it is. Why don't you just put the stuff in the calculator and write it like that. Hey, I prefer like putting everything in the calculator like at once, you know, and then just get like a final answer, you know. Now you may be thinking, isn't that like a bit risky? I think whichever way, doing multiple calculations is also risky because I'm like, you know, those are like many different options. Not many. What am I trying to say? It's also room for error, like, because every single time you put stuff in the calculator, that's like room for error. So if you just do it properly once, then you're good to go. So let's see here in the calculator, my value of k comes out as 1 over 4205. K is equal to 1 over 4205. So now we have a k value. We can throw that in there, and then we can throw in a y value of like 210 and work out x. So here, therefore, our y value here, we know it's like 210, right? So it's like 210, and then our k value, we worked it out to be 1 over 4205. X value is what we're looking for, minus 725 squared plus 190. I feel like I didn't use my own rule here. Hey, isolating x, this can go over. It's like 210 minus 190, and then you know, yeah, this paper, it was quite easy, to be honest. I feel like the last few papers I've been doing, that's what I've been saying so much. So let's see, divide both sides by this value. Is going to be 210 minus 190 divided by this. And then it's like x minus this. I keep saying this. You can hear, I'm sure you can hear from just the tone of my voice right now, like, hey, the boy is tired. This week has been long, and yeah, you can square root both sides here. So square root this, 210 minus 190, and then 1 with 425, yada yada yada. And then here you can just have x minus this, and then obviously you can just take that to the other side. That's gonna be another line. Yeah, ne? So it's like 210 minus 190 over this fraction here, yeah, ne? And then plus 725 equals x. Therefore, x in the calculator, let's see what all this is gonna be. In the calculator, we are getting two answers, obviously, because I mean, like, you see, the square root here comes out as a plus or a minus answer. So remember, you have to put here, technically you put a square root there, so you have to put plus or minus, otherwise you're not going to get two of your answers. But then in the calculator, you're going to put one with the plus, and then you're going to put one with the minus. So let's see. Here, getting 1015, or x is equal to 434. Obviously, we're going to pick the one that is, 435. We're going to pick the one that's closer to the left. So we're going to say here, therefore, it is 437. Let's say here, therefore, 435 meters horizontally. Wait, what is the question? Calculate the horizontal distance. Let's just say therefore this, you see, to show that we have chosen this one. That's that. Nothing crazy, nothing are major. Let us move on to question 10. This question is quite interesting. I remember it says here, a company sold shares at a fixed price of 875.5 per share over 5 years. So you see here, you have to remember these kinds of questions, they'll use many weird scenarios, but just remember that as long as it's financial math, just think of how financial math works, you see. Yeah, yeah. Oh, excuse me. So, for example, here they're talking about a company selling shares at this price for 5 years. You can almost think of this as like monthly installments for 5 years. And then it says here the minimum guaranteed interest rate earned over the 5-year period is 6.8 per annum compounded quarterly. You see. And then it says here Colleen purchased 10 shares every quarter. Colleen purchased 10 shares every quarter over the 5-year period. Wow. And then it says here her first purchase was at the end of the first quarter. Determine the percentage or determine the minimum profit. Determine the percentage minimum profit on the total cost of shares bought at the end of the 5-year period. So how many marks is this question? You see, it's a long question. It's out of 6. So as I said, these kinds of questions, you don't want to just read them once and then just move on or whatever. No. This is actually one of the questions I covered in the financial math course because I thought it was a good question. But anyways, it says here, this company is selling shares at this price for 5 years. And then this is the interest rate, right? And it is compounded quarterly. It says Colleen purchases 10 shares every quarter. So you can almost think of it as a scenario where whatever you're going to do here, before you can even worry about determining the percentage minimum profit on the total cost of the shares bought, before you can even worry about this, just find out how much her shares would have accumulated to after 5 years first, and then find out how much she spent for those shares. So let's see here spent first. So what she has spent is she's buying 10 shares every quarter. So it's 10 shares every quarter, but then this is for 5 years. You see, 10 shares every quarter for 5 years. You see, or you can even look at it this way. It's 5 years, and then she's buying shares every quarter. So she has bought shares 20 times. She bought shares 20 times, but every time she bought, she was buying 10 of them. You see. So this is 5 times 4, which is 20, times 10, this is 200. So she bought 200 shares. So these 200 shares, we know that she spent 875.5 for each of them. You see, 875.5 for each of them. So let's see what is the amount spent here for all these shares. Let's see, 200 and whatever. Let's see here, 200 and something. So she has spent a total of 175,100. Okay. So now let's see how much her shares have accumulated to. This is going to be a normal F formula scenario because it's her shares. You can almost think of it as monthly investments or whatever. So here F is equal to X 1 plus I to the power of N minus 1, the whole thing over I. And then here X, you want to remember that every quarter she's buying 10 of them. So meaning every quarter she's paying worth 8,750. And then the interest, they said it is 6% per annum compounded quarterly. And we know it's over 5 years quarterly, so it's like 5 times 4, which is like 20. And then interest rate is just 6.7% quarterly. So let's see what this gives us in the calculator. Let's see how much her money has accumulated to. Her money, according to the calculator, has accumulated to 205,973.485. This is not a final answer. So this is how much her shares have accumulated to. Let's see how much profit she made. You see, this is how much she got at the end minus how much she spent. 175,100. Let's see how much profit she made in money. Remember, we're going to work out how much she made in profit and then the percentage afterwards. So in the calculator, this is giving us 30,873.485. So let's read the question again. Determine the percentage minimum profit on the total cost of the shares. So you have to work out the percentage on the total cost. So let's see how much profit she made based on her total spent amount. So she made this much from the money that she spent, 30,873.485 divided by this number. Let's see what this is as a percentage. Let's check all this into the calculator. This is giving us a percentage of 17.6%. This is how much profit she made over a period of 5 years. Honestly speaking, this was a terrible investment. Like, what the hell, bro? Like 6.7%. Your money was basically losing value every year because this is below the inflation rate. But anyways, I'm not a financial expert, so let me just move on. Colleen took a bank loan of 300,000 at the beginning of the same year as she bought her first 10 shares indicated in question A and paid back the loan through monthly payments. Okay, her first repayment was made at the end of January of that year. Okay, yes. Then it says the bank offered her an interest rate of 9% per annum compounded monthly over 15 years. If she sold her shares at the end of the 5-year period based on the minimum interest rate, would she be able to pay the balance of her loan at that stage? It's an 8-mark question, so it's a lot of writing, but it's not complicated at all, because all we have to do here is to work out the balance of the loan after 5 years, and then we have to see if the balance of the loan is smaller than how much her shares would have been worth. So this is actually not a difficult question, Let's see, took out a bank loan of 300,000. So P is 300,000 at the beginning of the same year, yes, which is in January, when she bought her first shares, whatever, yada 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 yada. So so here we have to work out what is going to be her monthly installments here. We don't know. Interest rate 9.5% per annum compounded monthly, and then what else? N is 15, so it's 15 times 12. So we have to work out what her monthly installments are if she's going to cover it over 15 years, and then we just have to work out the balance of the loan after 5 years and then compare it to the previous question. You see, that's why this is just an 8-mark question, because we have to get the balance of the loan at some point and we have to work out the monthly installment here. So it's just like a lot of things that we're doing all at the same time, but not to say we're doing anything complicated. So here, let's see, 1 plus I to the power of negative n over I. Working out x, we're going to have pi here, the whole thing with 1 minus, you may be asking, how did you do that, bro? So here, to isolate, we're going to need to isolate x, right? So we can solve for x. So here, you can multiply by I on the left and on the right. So you're going to have here pi, the whole thing, equal to x, and then 1 minus 1 plus I negative n. And then you're gonna have here divided by all this. So pi here, you're gonna have 1 minus 1 plus I to the power of negative n is equal to x. And then what else now? Yeah, now you can just solve. Oh, I forgot the bracket. Now you can just solve for x, because in your calculator p is 300,000. What is the interest rate? I feel like for this question I should have just thrown in the clip from the course here, but I'm already done with the question. Interest rate. What is interest rate? It's like 9.5% over 12, and then what? It's like 1 minus interest rate. What is the interest rate? 9.5% over 12, and then n, we said it was, what is 15 times 12? Hey, we'll just have to do it in the calculator. 15 times 12. And then what you got? What you know about rolling down in the deep, blah 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 blah. Yo, like that song is stuck in my head, man. Like, damn it. Anyways, in the calculator, let's see what the monthly installment is. Okay, so the monthly installment is like 3,132, and then we have to, kind of got cut off there. It's 3,000. Let's see here, 3,132.67,404.9. And then what's next? Oh yeah, this is the monthly installment. You see, now you want to work out the balance on the loan. The balance on the loan is quite simple. You can just use this formula. You see, balance is equal to a minus f, of which your value of a is just p1 plus I to the power of n. Let's see here, what is p? 300,000. Interest is 9.5% over how many years? 15 times 12. So it's like 15 times 12. No. Balance on the loan after 5 years, bro. So it's like 5 times 12, which is like 60. So this is going to be a value of a, right? Of which that value of a in the calculator, let's just get that quickly. Let's just see here. Our value of a here is 481,502.8408. That is the way. I like it. Let's use a different color for f. Let's try and use a totally different color. Let's even use a white. Like, why not, So for f, you have to be careful now, because f is going to be the monthly installment, right? 3,132.67. Yeah, this is the annoying thing with financial math, needing to write all this. Like, I know, man. I'm actually trying to put this somewhere down. Move this here, yes. Move this here, yes. Move this here, yes. So what you got? F. Nah. I feel like I should just make this smaller, because I'm like wasting space here. Make this. Ish. Alright, let me stop being a baby. This is just like 1 plus I. I is like 9.5% over 12. It's compounded monthly years for 5 years. And then this is over interest. So let's put all this into the calculator, see what our f value is. In the calculator, our F value is coming out as 239,000. Let's see here, 239,405.9954. So you see, therefore the balance is just these two. Balance, my goodness, is balance yaga. You see, balance is just A minus F. So let's see what A minus F is in the calculator. Let's see, 242,096.85 if you round it up to 2 decimal places. So that's the balance that we're getting when we say A minus F, you see. Of which clearly A minus F, this is the balance on the loan, and then this is what her shares are going to give her. So clearly she won't be able to pay off the loan with the money from her shares, you see. Yeah. So here you can clearly just say no, she will not be able to pay off the loan after 5 years. Okay, so let's say here, no, she will not be able. Let's see if they wanted a reason. We already have a reason. All these calculations. No, she will not be able to pay off the loan after the 5 years. Then you end it there. Whew, here's a long question, yeah. Okay, so we have another really strange question here, like yo. It is, yeah, let me not say it because that is just too washed out now. This is the infinity symbol. I is equal to 1. I is over there. I is equal to 1. 2i over here. Where is this thing? 2i. There we go. So what else you got? So all this being done, they said the following. They say determine the smallest value of k for which the left side is going to be bigger than 1 million for all values of k. I mean, for which k is an integer. So k is going to be an integer, meaning it's a complete value. They just want you to work out where the left side is bigger than 1 million. So the one thing I can safely say is what? Just be able to break down your expressions, because remember, anything with an infinity symbol here, this is going to be for a geometric sequence, or a geometric series, whether you like it or not. And also, anytime you see that your variable here is an exponent, you see variable is an exponent. Why is this thing so big, though? So let's say variable, let me write this out. Come on, I can do better. Variable is an exponent. If your variable is an exponent, then you're basically dealing with geometric as well. You see, so don't forget that. So we're just dealing with the geometric series here and the geometric series over there. So remember, anytime you see sigma, you literally just need to choose an SN formula that you're going to use to answer the question that they would have asked, or to break down whatever expression you will be faced with. So this expression here, it's a geometric series, but then it's also just clearly showing you sum to infinity because of the infinity symbol, you see. So you know that for this left part, you're going to use your sum to infinity formula. You see, sum to infinity is equal to a1 minus r. The other one, there's no sum to infinity here, so you're clearly going to use the normal SN formula. SN is equal to a rn minus 1 over r minus 1, because that's what sigma is. It's all a matter of using an SN formula, either the arithmetic one or the geometric one or the sum to infinity. So for the sum to infinity here, clearly we need a, which is what we get when you throw this number where I is. So let's get A for the first part here. You see, for the first part, I'll put it in green. Let me put it in green here. You see, because you may be asking yourself, bro, what are we doing? Is here they say determine the smallest value of k for which this plus this is bigger than 1,000,000. All you have to do is get a number for this expression, get a number for this expression, or get a value for this thing here, get a value for this thing here, and then just solve for k. You see, so here we're saying where a is, for us to get a, it's just a matter of throwing this value where I is over there. So that's going to be k over 2. And then r, we know that r is going to be equal to t2 divided by t1. You see, so t2, you're going to throw 2 over there. So it's like k over 4 divided by t1, which is like k over 2. Of which, if you simplify, this is just going to give you, I think it's a half. Yeah, a half. If you simplify, because you're going to flip this over, and then the k's are going to cancel each other out. You see, because here, let me put an extra step, just in case, you know, the peeps may be asking, bro, how did you get a half? So obviously, tip and times, you're going to get times 2 over k there, and then a half. That's your value for r. So here you can see, therefore, your sum to infinity for that expression here, it is just the following. A is k over 2, r is just a half. So you can see here, this is just gonna give you k over 2 divided by a half. It's gonna be k over 2 times 2 over 1. This is just k. Okay, so your sum to infinity here is just k. That's this green part. Let's do the blue. The blue, we know it is this part. So this is just saying, in the SN formula, we have to get a value for a, right? A is what you get when you throw this into your expression. So this is just going to be 2 to the power of 2. So that's just a 4. And then our value of r, remember, it's t2 over t1. So t2 is what you get when you throw 2 over there. So that's like 2 to the power 4. And then t1 is what you get when you throw 1 over there. So that's like 2 to the power of 2. So your base is the same, you're dividing. So you can subtract exponents. This is just going to give you a 4. Okay. So now what? What you gonna do? What you gonna do when they come for you, pebbles? What you gonna do? We have a, we have r. Now we need n. N, remember, it's always the end minus the start plus 1. The end is the number at the top. The start is the number at the bottom. So here the top is like 10. The bottom is like 1. So n here is just a 10. Now we can throw all these values into our SN formula. S10 is equal to a. What is a? A is a 4. R, we worked it out to be a 4 as well. Okay, interesting. N is a 10 minus 1 over 4 minus 1. Let's see what this S10 is in the R calculator. Okay, let's see. So in the calculator, that is giving us 1,398,100. 1,398,100. Okay, so now we have a value here. This is k plus that. Where is it bigger than 1 million? So here we now can just carry on and say, therefore, k plus this, where is it bigger than 1 million? You see, so working out k, so this goes over, so it's going to be k has to be bigger than -398,100. So this question, nothing crazy, nothing major. It's all that you have to put. You see, you can just say k is bigger than this, but then remember here they say that k has to be an integer. So here you also have to specify that it is bigger than this, yes, but then only consider integer values for k, you see, because remember, you just leaving it by saying k is bigger than this, it also implies that k can be a decimal, you see. It can be like, let's say like negative 300,000 point something something, you see. That's not true, because we have to make sure that we specify that k is bigger than this, yes, but then k should only be considering like values that are complete and not values that have any decimals. That's why this is important for you to get the entire 6 marks. Whew. Moving on. They say, looking at this arithmetic sequence, we should determine the number of terms in the in the series. So this is easy because this is where we're starting, this is where we're ending. Now remember, for an arithmetic series, you know that your general term is just Tn is equal to a n minus 1d. Now the common difference here is just this value minus 5, 15 over 2 minus 5. A is just a 5, n you don't know, but then if you're going to work out the number of terms, you just want to work out the position of this value here, you see, of which the position of this value is n, but then itself it is actually just 505 over 2. So working out n, you can just make n the subject of the formula. So making n the subject of the formula here, you can just take the a over, let's see here, n minus 1d, and then divide both sides by d, Tn minus a over d, and then take the 1 over, you can have Tn minus 1 over d, and then here plus 1. So here let's just throw everything into the value, into the formula. N is going to be equal to Tn, right, which is like 505 over 2 minus a, which is a 5, the whole thing over d, and the whole thing plus 1. Okay, let's see what n is in the calculator, because I'm like, why not, right? Why the no hot? Why the no hot? In the calculator, n is just 100. Easy, man. Easy question. For 4 more marks, they said calculate the sum of the middle 30. Calculate the sum of the middle 30 terms. Yo, that's weird. Well, you can think of it logically, because if you have 100 terms, the middle 30 terms, you have to think of it, it's like 70 to, it's like 35 to the left, 35 to the right, because if you have 30 here, it means that the rest have to make up 70 out of 100, because look, this is 35, this is 35, you see, and then you have 30 in the middle there. They want us to work out the sum of these 30 over there. So if you think of it, term number 1 is 5, and then the value of d, as we worked it out, it is just 15 minus 5. If you put that in your calculator, that's just like 5 over 2. Yeah, excuse me. So with all that being done, what we know is, if you think of it nicely, term number 1, 2, 3, all the way until like term number 35, we know that in this, with these values here that are in the middle, these 30 that are in the middle, you obviously start off at T36. You see, T36 is the first one in this values that are in the middle. So if you're going to work out the sum of the 30 in the middle, you want to work out the sum of terms starting from term number 36 until 30 terms forward, you see, because from term number 36, 30 terms ahead is like 36 plus, it's technically 36, 37, 38, going on and on and on and on, all the way until this is like 35 plus 30. So this is all the way until But then wait, 30, we have to just think, yo, good lord. Why? Let me just do like a funny, a mini sigma thing. Because look, you're going to add up terms, starting from where n is equal to 36, all the way until where n is equal to 66. And then the general term is just what you have over there, right? Like a. What is a? I feel like I'm about to make it more complicated than what it is. No, I don't think I am. A here is just what did we get as a? A is a 5, because that's how sigma is. The value where you're ending, where you're starting, and then the general term here. So this is like a plus n, and then minus 1. The value of d is 5/2. So this is what we need to do, you see, meaning we can just use our Sn formula. So here Sn, we know that it is equal to n/2, 2a, and then n minus 1 d. So here the sum of, let's see here, n, we know it is going to be equal to 66 minus 36 plus 1. This is just adding 30 terms. And then a, remember, you have to be careful here. A is what you get, as we said already, a is what you get when you throw this into your formula. You see, a is what you get when you throw that in there. You see, that's how you get your value of a. So a is going to be 5 plus 36 minus 1 d. So a here, what you get, let's find out in the calculator. Let's just put everything into the calculator. So everything into the calculator, it is like 185/2. Over 2, that's your a. You see, you have n, you have a, and then d is still just 5/2. So let's put all this into the Sn formula. So the sum of the first, so this would be like S30 in that sequence, starting from there to there. This would be equal to 30/2, 2a. What is a now? A is like 185/2. And then n, what is n now? N is like 36 minus 1. What is d? Hey, let me see here. D. What is it now? Yeah, n/2, 2a plus n minus 1. What is d? D is going to be 5/2. There we go. So here we just have to put everything into the calculator, do we? Yeah, we do. Let's see what this gives us. Oh, made a mistake here. It's supposed to be 30. It's supposed to be 30, bro. Let's see. In the calculator, all this is giving us 3,862.5. 3,862.5. Nice. So this question was quite interesting. You definitely did have to think outside the box a little bit. Otherwise, you know, it was gonna be a bit difficult and a bit challenging. But don't worry about the whole sigma part. You could have just said to yourself, okay, fine, I'm just starting from term number 36. You work out what it is, which is just this value. And then you know that you just have to add 30 terms going forward. So n is just going to be 30, d is just this. So you don't have to worry about this too much, you see. Anyways, let's see. Moving on to the next question, the second last question, because there are 13 questions in this thing. It says the graphs of G and H touch when x is 1. Therefore, the tangent to the curve at G at x is equal to 1 is also the tangent to the curve at h, where x is equal to 1. Okay, it's quite interesting. Then it says determine the coordinate of the point of contact of the two graphs. I'm scrolling down to see the marker location. 8. Yo, goodness. So we just need to work out the point, the what? Yeah, the point where the tangent and the curve meet. So because this tangent is going to be a tangent to both curves, it's best that we use oh, I see. The two equations are not complete. Okay. That's interesting. So I guess we can work out A and B simultaneously. Oh, well, I don't know. Let me not say anything. Let's just work it out as we. So this is an equation of a cubic graph. This is an equation of a parabola. And then it says here they touch when x is equal to 1. So meaning when you equate these two equations together, this is a factor of that equation. You see, this value here satisfies the equation that you get when you equate these two. Like, for example, g of x is equal to h of x. Where they meet, you know that the equation of g, let's see it here, minus ax squared plus 6. This equation of g here is equal to the equation of h there, 2x squared plus bx plus 3. So putting everything to one side here, you're gonna have x cubed minus 8x squared, and then here you're gonna have minus 2x squared, and then the b comes over, minus bx, and then 6 minus 3 is gonna be like my positive 3 there. So here's everything on the left. If you wanna put it in let's say in standard form, then you're gonna have x cubed. This is x squared, right? So it's easier if you do like let's take out I want to take out x squared as a common factor here. So you're gonna have x squared here, right? So you're gonna have negative a, negative 2, and then here negative bx, and then plus 3 is equal to 0. So this, it's easier if you write the x squared there. You see, it's easier to, like, look at and stuff. So let's just do this, because it really doesn't matter if you write it in the front or in the back, but it's easier to write it in the front like this, so that at least you see that the coefficient of x squared is just that bracket. Whew. So with this being done, they told us that these graphs meet when x is equal to a positive 1. So it just means that if you throw a positive 1 in here, it's a point where the graphs meet, you see. So remember, this being equal to this, they meet where x is a 1. So where x is a 1, that's where the graphs meet. So you can just throw a 1 in there, it will still satisfy the equation. Let's see here, b 1 there, 3 equal to 0. We're throwing 1 in there because the graphs meet where x is a 0, where x is a 1. So this is equal to this where x is a 1. So here this is just going to be 1 plus well, here let's just remove the brackets now. So this, if you multiply inside, is just that, and then minus b plus 3 equal to 0. So we have an equation that's in terms of a and b. Simplifying some more, it's like 1 minus 2, that's like minus 1, plus 3, that's like 2. And then it's like minus a minus b equal to 0. Let's just take the b over. So it's like 2 minus a is equal to b. So we have an equation in terms of a and b here. I'm pretty sure we can get another one. Can we get another one? Hey, who knows, man? Yeah, probably, because they said here we have, therefore the tangent to the curve is at x is equal to negative 1. Remember, a tangent and a curve have the same gradient at the point that they meet. So let's exploit that thinking. A tangent and a curve have the same gradient where they meet. I feel like that's one thing I always say it over and over again in like the tutorials on the main channel. So let's see here. This is a curve, right? It has the same gradient as the tangent at the point of contact. So let's see here. Let me write here h of x. I feel like I should zoom in and write better, because if I don't zoom in I keep wasting space, you know, keep wasting the space. So let me zoom in and write better. H of x, it is equal to 2x squared plus bx. Yo, they're going up and down. Hey, is that necessary? So this is the this is the one curve, right? We know that where x is a positive 1, it has the same gradient as the curve. I mean, as the tangent. So we know that let's get its gradient equation. Its first derivative, it is going to be 2. No, it's going to be 4x plus b, because 1 times b is a b, 1 minus 1 is a 0. And then the derivative of a constant, it just falls away. So this is the gradient equation of the curve. And we know that the gradient of the curve is always going to be the gradient of the tangent at the point where they meet. However, the point where this curve meets the tangent is also a point where the other curve meets the tangent as well. You see, so our cubic function here, its gradient equation, right? Let's see what it's going to be. So this is the original cubic function, right? It is the following: ax cubed minus ax squared plus 6. So if you have the first derivative here, it is 3x squared minus 2ax. That's the first derivative. You see, this times this is that, 2 minus 1 is that. So, and then 3 times 1 is, I think everything looks fine here. So what we know is the gradient of the curve of this parabola will be equal to the gradient of this cubic function at the point where they both meet the tangent, you see. So meaning for this kind of equation, right, we just have to make the first derivative of the parabola equal to the first derivative of the cubic function, because we know that where they meet, they are both having a tangent at that point, meaning that at that point where they meet, they are both going to have the same gradient. So that's why we're saying the gradient equation of one here, we're equating it to the gradient equation of the other. The good news is, what we know is the x value where those gradients are equal, we know that the x value is just a 1. So this is quite an intricate question, and that's why these papers are good practice, you see, because I'm like, you get to see all this intricate stuff. So anyways, this is 4 plus b, this is like 3 minus 2a, and what you gonna do when they come for you? Let's see here, let's isolate b as well, or rather let's just throw the equation already, you know, like this equation of b, let's just throw it into the thingy already. Let's just throw it in there. You see, this is equation 2, let's just throw it in there. So carrying on here, we're gonna have 4 plus let's throw a b value there, 2 minus a, and then this is 3 minus 2a, and then here you have like 4 plus 2 minus a, 3 minus 2a. What else? What is 4 plus 2? That's like 6. And then to make solving for a here, it's like negative 2 comes over, and then 3 minus 6 over there. So this is like a is equal to negative 3. And I'm still thinking to myself, what was the question again? Determine the coordinates of this point of contact of the two graphs. The coordinates of this point of contact of the two graphs. So you see, we have the x value of the point of contact. Well, we just need the y value. And for us to get the y value of the point of contact, we at least need to get one of these equations. So it doesn't matter what we're going to get here. If we get a, it's fine. We'll just throw a in there and then throw 1 into the equation and then get the corresponding y value. Like here we have gotten a, which is good enough. So because now we've gotten a, we can just use that in the main equation. Like in the main equation, we can then say here, therefore the graph of g of x, not enough space, but we don't need a lot of space. We just need a small little bit. So therefore the graph of g of x here is equal to the following. You see, the graph of g now, by default, it is then equal to x cubed minus, no, it's going to be x cubed plus 3x squared. Let's see here, x cubed plus 3x squared, because a minus and a minus gives you a plus, and then you have plus 6 over there. And then what else? So now here we have the equation of one graph. So here we're gonna throw in an x value of 1 for us to find out what is its y value. 1 over there, 1 over there. So let's see what this is now. This is like 1 plus 3, that's like 4, plus 6, that's like 10. You see, so therefore the coordinate is just 1 coordinate 10. That is the point of contact, and we use this value of 1 so many times, it's just so crazy, but it is what it is, man. Like legit, gotta do what you gotta do, gotta do what you gotta do. So this clearly was a lot of writing, but yeah, it looked like it was all worth it, to be honest, because it doesn't look like there's a step here that you could have like skipped or something like that. I just know that I wrote down everything as best as I could, bit by bit and all that. So let us move on to the last question. Anyways, question 13, here we go. It says the frame of the box indicated in the diagram is made up of 12 plastic rods. Okay, yeah, because it's like 1 2 3 4 5 6 7 8 and then 9 10 11 12. Okay, yeah, the frame of the box indicated in the diagram is made up of 12 plastic rods that have a total length of p centimeters. Okay, and then it says the width of the box is half the length. Okay, that's why this is x and this is 2x. Nice. I think this is also one of the questions that are showcased in the applications of calculus course, but we'll see. It says, the next thing here says the following. If the volume is a maximum, determine the length of the box in terms of p, showing all workings. Whoa. Wow. Okay, so for 8 marks, I just think it's going to be a lot of writing, but not necessarily something difficult, because firstly, as they said here, volume is length times width times height, but the only issue is our height here. We need to be careful so that we write it in terms of like a variable or something like that. What I mean is, firstly, what have we been given here? They just gave us p, so we know that p, which is the length of everything, it is just h plus h plus h plus h, which is 4 of them, and then it is equal to x plus x plus x plus x, which is like 4 of them, and then 2x plus 2x plus 2x plus 2x, which is like 4 of them. You see, so let's simplify what p is actually. So it's like it looks like it's going to be, let's take out, I feel like, no, it's just going to be 4p. Let's not complicate it. 4p plus 4x plus 8x. Simplifying some more, it's like 4, I meant h, not 4p, 4h plus, this is like 12x. This is what p is, you see. They say we should, if the volume is a maximum, determine the length of the box in terms of p. The length of the box in terms of p. So I think we can get a value of x in terms of p. So we can throw x there and then have the length in terms of p. Let me say that again. It looks as though it's best for us to get a value, an expression for x in terms of p, and then throw that here so that we can have 2 times that value, which will be the length of the box in terms of p. So the only issue here is that our expression here has h. So we have to do something for us to not have h anymore. So the only thing we can use is what they said here. The volume is a maximum. So if the volume is a maximum, then remember, firstly, our volume, right, is just length times breadth times height. So it's just length times the width times the height. This is what the volume is. The volume, it is just 2x squared, or let's just say 2 hx squared. This is the volume. Now if this is our volume, right, let's make our volume in terms of x. So if our volume is in terms of x, then it means that if our volume is a maximum, then we need to make the first derivative equal to 0. For us to work to get the maximum volume, or for us to get the value of x, which causes the maximum volume, we have to differentiate and equate to 0. So our volume function, we have to differentiate it once and then equate it to 0. So differentiate it once. Everything that I'm doing now, I promise you, the applications of calculus course is what you need if this is still a bit difficult. So we have differentiated once, we have made our equation equal to 0. Now we're going to get an x value that will cause the volume to be a maximum. So the x value that will cause this volume to be a maximum, it looks as though x is going to be a 0. But how can that be? Clearly that would be what will cause the volume to be a minimum, you know, because I mean, like, if x is a 0, then the volume will be a minimum. So let me just say here, volume would be a minimum. Volume would be mean. Okay, so that I can just not carry on going anyway here. Okay, so I see I bombed out over there. Let's look for other clues that we have missed, may have missed. The frame of the box indicated in the diagram is made up of 12 plastic rods. What else? That have excuse me. That have a total length of p centimeters. Okay. And then they said all that they've said there. The volume of the rectangular prism is just length times width times height. So I just need a value of height in terms of p or x. So they say the volume is a maximum. You know, the volume is a maximum. The volume is a maximum. The volume is a maximum. Differentiate and equate to 0, they said. Differentiating and equating to 0 is not working, man. Like the first time ever. It's not working. X is cut to 0. Then it just means that if x is 0, volume is... Yeah, this is a difficult one, eh? I'm gonna need to pause and think about it. Anyways, before I do carry on thinking, what I'm thinking is let's maybe do what? What you thinking, my friend? What you thinking? I was thinking let's maybe do this. Let's remove this, and let's try and not have h, because it seems like h is our problem really. So let's write h here in terms of p and x. So here you're gonna have the 12x go over. It's gonna be like this, and then you're gonna divide by 4 on both sides. So obviously you're gonna have like p over 4, and then this is like 3x, negative 3x. So since this is the volume, let's throw our value for h in here, right? Let's throw our value for h in there. So volume is equal to 2x squared. Our value of h is just p over 4 minus 3x. So let's simplify. If you multiply inside here, this is going to give you 2x squared p over 4, and then that's like 6x cubed. 6x cubed what? 6x cubed what? Yeah, this is just 6x cubed. So let's do this. There we go. If you want to simplify, what can you do here? This is gonna be like bro, what is going on? So v here is gonna be equal to x squared p over 2, because this is like 2 divided by 4, that's just a half, so it's like a 1 here and a 2 down there, and then this is still just 6x cubed. Okay, so here I think we have a chance, because now it looks like we can differentiate in terms of x and equate to 0 and actually end up with an answer. So let's see here. If we differentiate here and we make x the subject of the formula, so let's differentiate in terms of x is what I wanted to say. So let's do this, do that, do this. So here let's just simplify first so that we can clearly put this in such a way that we can differentiate using the power rule. So let me write x there. So here it's going to be p over 2. This is the coefficient. Then you have x squared there minus 6x cubed. You see, we haven't differentiated yet. We have just been simplifying. So because they said here volume is a maximum, let's get a value of x that results in the volume being a maximum. You see, so here the value of x that results in the volume being a maximum, you're going to get that, you need to differentiate your expression and then make it equal to 0. So this is 2 times this value, which is just going to give you a p. Remove 1 from the exponent, and then 3 times negative 6, that's like negative 18x squared. So this is like what? This times that gives you this. I mean, this times this value gives you this. This times this value gives you this. So this is your first derivative, right? You're going to make it equal to 0. This is like px minus 18x squared. Take this to the other side, 18x squared. This is equal to like px. And then we're going to divide both sides by... what are we going to divide it? Well, clearly we can divide both sides by x here. For now, see, divide by x, it's going to give us 18x equal to p. So we said here, remember, they said if the volume is a maximum, determine the length of the box in terms of p. So for us to get the length of the box in terms of p, we have to get a value for x to throw there. So let's see here, x is going to be equal to p over 18. Therefore, the length is going to be 2x, which is equal to 2 times p over 18, which is just going to be p over 9. What a wow, what a wow. So this is the answer that we are getting. I know it is quite interesting that we get such an answer, but we finessed it, we finessed it as best as we could, and it is what it is. So anyways, that's that from the side of the me. Whew. With a lot of stuff that I mentioned, right? Like, this is me being as honest as I honestly can be. You would want to take the time to go sign up for the online courses. You see, courses.youngbrains.co.za. You want to head over to that website, and you want to what you want to do again. You want to sign up for the online courses so that you can get more insight on a lot of the items that I was mentioning and a lot of the methods that I was using. Because remember, it's not a once-off thing. You can't just look at something once and think to yourself that you've learned it, you see. But anyways, that's that from my side. Enjoy the rest of your day. Me, I'm happy that I've finally gotten to do this paper, because I'd been putting it off for so long, but it is finally done now. Like, oh my goodness, it feels so good. Kiki. So all the questions done from start to finish. Anyways, I keep saying anyways. Let me just go here. Let me just go. Oh, don't forget to like, subscribe, and tell your friends that this is what we do on this channel. What am I doing? What am I even saying? Well, all I'm trying to say is, if you see that these videos are like helpful and like you learn a lot and all that, then obviously don't be selfish. Just let the others know so that they can also benefit.